The Shiki Science Show clips.
So the best place to start is with NAD itself. So NAD stands for nicotinamide adenine dinucleotide, and it is one of the most abundant molecules in the human body. It is important not only as a coenzyme for different redox reactions and for energy metabolism, but also as an essential cofactor for different enzymes, notably the sirtuin family and poly-ADP ribose polymerases, known as PARPs, that are important in DNA repair. But it is thought that there are more than 300 enzymes relying on NAD+ for their activity. So I think we can say that NAD+ is pretty important. However, NAD+ levels have been shown to decline as we age when there's high amounts of DNA damage, which is partly due to the activation of these PARP enzymes and due to sirtuin activity, and also during alcohol metabolism. And so for these different reasons, there's a lot of interest at the moment in trying to restore NAD+ levels to alleviate some of the symptoms associated with NAD+ decline. But before we go into some of these methods, we really need to understand NAD metabolism and how it works, otherwise what I say could just sound like a load of gibberish. So in my opinion, the best way to understand it is to understand why NAD+ is called nicotinamide adenine dinucleotides. And that can be seen by looking at its structure, where I've indicated different groups of the compounds and where the name comes from. So the first part, nicotinamide, comes from the fact that it has this nicotinamide group attached to a ribose molecule. The second ribose molecule in NAD+ is attached to an adenosine group, hence the nicotinamide adenine aspect of the name. And then the last part, dinucleotide, refers to the fact that these two ribose molecules are attached through two phosphates, and this is similar to the backbone of nucleic acids. And so each nucleic acid is otherwise referred to as a nucleotide, and so you've got a dinucleotide present. And so the reason I went into so much detail here isn't because I love biochemistry, which I obviously do, but because it helps us to understand how NAD+ is generated and then consumed within a cell. And so it's thought that there are 3 different pathways within a cell that can generate NAD+. And these 3 pathways are nicely summarised in this figure from a recent review article on NAD+ metabolism, which was a good source of information for this video. And so on the far left, you can see that there's the de novo pathway to NAD+ formation that starts from tryptophan being an amino acid. As you can see, there's quite a few steps that take tryptophan through to NAD+. And for these reasons, some of the enzymes involved in these steps aren't expressed in all cell types, and so it's thought that this de novo pathway is mainly occurring only in the liver. The second pathway to NAD+ is from vitamin precursors known as nicotinic acid, or you might know it as niacin, and this gets converted to NAD+ via the Prius-Handler pathway. And the last method is the so-called salvage pathway, which generates NAD+ from nicotinamide, NAM. So if we go back to the biochemical structure of NAD+ that I showed you earlier, nicotinamide is just this moiety group at the end that I've indicated. And the reason it's called the salvage pathway is because when NAD+ is consumed by different enzymes within the body, such as sirtuins and PARPs, one of the products is nicotinamide. And so nicotinamide can be converted back into NAD+, and therefore effectively rescue the NAD+ levels. The way it's converted back is by going through an intermediate known as NMN, nicotinamide mononucleotide.